Hello, everyone. I am not muted. Hooray! Awesome. I am your host, Annie Wilson, and this is Daily Space. And yes, for those of you paying attention to the tags on Twitter, no, not Twitter, this is Twitch, not Twitter. To the tags on Twitch, I have added the AMA. So please, when you ask questions, at me, and if I don't know the answer, somebody in chat will, and we will find you an answer, as we just demonstrated in the pre-show chat. So yeah, I have three. I think three. Numbers are hard. This is like, I feel like this is like my third day in a row doing this, but it's only Tuesdays, so we'll just roll with that. Anyway, so yeah, I have some news stories, astronomy related for you. During the news story, if you have a question at me, I will pause between each news story to answer the questions that popped up. And afterwards, we can talk about a bunch of astronomy related things. And with that, let's do this. And now I have to find the next thing. All right. So here we have a beautiful image from Griffith Observatory showing a lunar impact, which is kind of hard to see, but you see this little bright spot right here? That's where a meteoroid hit the moon, and we caught it on tape, on film, whatever you want to call it. So that's cool. And yeah, on the YouTube clip that it was on, it's literally less than a second. It's a blip, which is why I'm showing you a still instead of a video image, because I had to slow the video down to like quarter speed just to really see it, and it's literally just boop, and then it's gone. So yeah, we have witnessed a lunar impact during a lunar eclipse because so many people were staring at the moon, and that's freaking awesome. So, yeah, isn't this picture beautiful? It's a great picture of the eclipse. It's a great picture of the moon, and I love that little boop that's right there. So, Zion asked, did they do a follow-up with a big telescope to find the new critter? Probably not yet. If they do, they probably won't release it for a few weeks, months, days. Pick one. That's just how this goes. It does take a while to get new data into the public hands. So, and Ed Thompson points out, LRO is up there though, maybe it'll see it. That's quite possible. It is very possible that LRO will see it. Blech. Alright, so, on to the next story. So this is Titan, an image of Titan. This is near infrared color. Let me move my notes so I can see it. And it is taken of the North Pole, which is this region up here. And this was an image taken by Cassini, which is no longer with us, unfortunately. So, before I continue, you need to know these three things. 1. Titan is the only moon known to have a dense atmosphere. 2. Titan has seasons and seasonal weather patterns. 3. Titan's methane cycle is like Earth's water cycle. And as a refresher, Earth's water cycle essentially is rain comes down out of the sky, it goes into large bodies of water, it eventually evaporates, it forms clouds, it repeats. It's way more complicated than that, but that's the brief overview. So, knowing these three things, it means it rains methane on Titan. Just hold that for a second. Process that. It rains methane on Titan. And we can see this with with, our satellites and space probes and things of that nature. And we actually, yes, have seen and anticipated, like, the seasonal weather patterns that do bring rain to, like, the poles and stuff. So, yes, it rains methane on Titan. But wait! There's more! Normally clouds, the atmosphere is mostly made up of nitrogen, but they have clouds of methane. This blows my mind. So normally clouds and rain come to Titan's poles in the summer season, except the rain came a bit early to the North Pole and without clouds. Process that for a second. The rain came, but there were no clouds. So that raises two questions. How do we know there was rain without clouds? And how in the world does it rain without the clouds? So, here's the answer to the first question. How do we know that there was rain without clouds? Images from Cassini. So, you know how you go outside after it rains and you see that the sidewalk's wet and the road is wet, and even though you may not have seen or heard the rain, you know it rained? It's kind of an oversimplification of what's happened here. Here they have the wet sidewalk ephemeral region, which is right here. So this is just one big blown up image after another. So here's where they see that it's wet from methane. Here are the clouds in the purplish, which is also right here in the purplish. And the specular reflection, which I'm assuming that's just reflection of stuff. So that's how they know it rained without clouds. They were literally able to see it from the data from the telescope. Spacecraft. Cassini. So that answers question number 1. Question number 2, how does it rain without clouds? We have no idea. No idea how this happened. Because they were all waiting for the clouds and the rain to come to the poles to signify that it was Titan's summer, and suddenly they see evidence of rain without clouds. So we do know that we haven't observed Titan's weather patterns long enough to know whether or not this is normal. Because this may be a totally normal thing, but we just haven't watched it long enough, like we've watched our own weather here on Earth, which we've literally recorded for hundreds of years. We don't know if it's normal or not. It would be cool if we knew, but we literally don't know if this is normal. This could be totally normal, it could be abnormal. We have no way of knowing what is normal, and we have absolutely no idea of how it rains without clouds. Because that's just... And I'm going to pause and look at chat and see if you guys have any questions on this. As I pull up the right window. Veronica points out that on Earth the clouds move fast enough that by the time the rain hits, the sun is shining. Possibly. Pernor says sublimation, perhaps? I think sublimation is a solid to a gas. Hazanko says stinky rain too. Yeah, I imagine the rain would really, really stink. Really, really stink. I'm scrolling up. How much area are we talking about on the front side of the moon? Is it US sized or less? For the impact, I have no idea. I really am terrible at processing size differences. So they could be looking for a new crater in the size of the US. Or maybe it's smaller. There's part of me that's like, it hopes that it's smaller. Hanny says, how does Io not have an atmosphere? It has volcanoes going off constantly. It may have an atmosphere. I really am not entirely too sure about it. I know that Titan has a dense atmosphere, and that does make a difference. Rain or snow? They call it rain, but I guess due to the gravity on Titan, the rain actually falls at the same rate that snow falls on Earth. So it's a really, really slow rain. Somebody said it's 2 times the size of China. Oh my goodness, that's huge. Where does the rain come from? Methane clouds. Like, literally the water cycle. There's just methane and it rains methane. Isn't methane actually odorless? Somebody else probably answered this. I thought they added smell to methane so people could smell there was a leak. I think you're correct. You are totally correct. Yes, methane is odorless. So no, the rain doesn't stink. We think it stinks because we added, things to our gas to make sure that, we know that things are leaking, because that's terrifying to just die a slow and long death because there's no oxygen. At room temperature and standard pressure, methane is colorless, odorless gas. Yeah. Yeah. That is mildly terrifying when I think about it. Pure methane is also rare in nature. This is also good to know. Or a quick death if you light a cigarette. Oh my goodness. Alright. Alright, so I'm going to move on to the next story. So this is a very, very pretty picture. It was released for the public this morning. And it is the planetary nebula called ESO, it's Echo Sierra Oscar, 577-24. And this was captured by ESO's Very Large Telescope. And planetary nebula are the result of giant red stars dying, and when they die, they throw off their outer layers, which leaves behind a small super hot dwarf star. So, yeah, they've known about this object for many, many years. It's pretty. It's really pretty. In the very, very center, you can see the star, and there's, all of this gas, which is from, the red giant, and over time, the gas just kind of billows out and explodes. We have kept track of and imaged a planetary nebula where you can actually see the gas dissipating. I don't know if this is going to be the case for ESO's image, and I think some of those images were taken like months or years apart. I'm gonna check chat for questions. Y'all are still going on about the gas. That's fine. All right. So this leads nicely into this image, which is an artist's rendition. This is not a real image pulled from space. This is an artist's rendition of a white dwarf, and you can see they have it cut away, and they're showing the crystal inside of the white dwarf. They have theorized for many, many years that white dwarfs do crystallize, but we finally have direct evidence that yes, white dwarf stars indeed crystallize like water turning into ice. University of Warwick astronomers discovered this. And this is a normal process that happens after the stars have ran out of fuel. When they run out of fuel, they can no longer heat themselves. Think of taking a pot of boiling water and shoving it in the freezer. So you remove the heat source. Water tends to hold on to heat for a while, but it will eventually freeze. So it slowly, slowly, slowly loses all of its heat and then freezes. You know, the water molecules actually form a crystal and freeze into ice. I had a thought here. Oh, that was the thought. A random aside, hot water freezes faster than cold water because the water molecules actually have more energy to align themselves into the crystalline pattern they need to form. Yeah, this is pretty cool. So, yeah, this is a pretty picture. This is a pretty cool thing that we've verified that this is indeed a real thing. So why is this important? Here's why it's important. White dwarf stars are some of the oldest objects in the universe. Astronomers literally use them as kind of a cosmic clock to determine how old groups of neighboring stars are. So they can predict, because white dwarfs have a very predictable life cycle. Words are hard. Because white dwarfs have a very predictable life cycle, you know, oh, here's this group of stars. Well, this white dwarf is X years old. Please add scale. So this group of stars is probably X minus 1 years old. Yeah. So they're useful and they're used a lot. What this discovery really means is that these white dwarfs are billions of years older than previously thought. In short, our cosmic clocks are off. Yeah, our cosmic clocks are off. All this other work that had been done of, oh, this group of stars is this age, this group of stars is that age, all of that may potentially have to be redone and change our understanding of the age of different objects as we know them. That's not terrifying or anything. It's like being plopped down into a new time zone halfway across the world without realizing you're being plopped down in a new time zone, and suddenly everything is off by a lot. Yeah. Yeah. That's mildly terrifying. So I'm going to pull up chat. Ed Thompson says, so the universe could be much older than we thought. Yep. Zine asks, does this mean our cosmic distance scale is off too? Potentially. That's a really good question, and I don't know the answer. Yeah, it could potentially screw a lot of things up. Be like, okay, time to update all the textbooks. Graham asks, how can they be frozen on the inside and hot on the outer layers? So frozen is a bit of a misnomer. It's solid on the inside and hotter on the outer layers. What happens is one of the elements, either carbon or oxygen, because it's both carbon and oxygen that are left, crystallizes and becomes a solid first and kind of sinks to the center, and the other things are, still in like a liquidish state above that. Excuse me again. It's kind of like the core of our Earth, which is solid and then surrounded by all of this lava. I'm probably screwing this up a little bit, and if I get this wrong, please correct me in chat, seriously. But essentially, a lot of pressure does weird things to some elements. If you add more pressure, liquids can actually become solid. Gases can actually become liquid. Same thing if you add temperature to the equation. This is something I vaguely remember from organic chemistry, of looking at how temperature and pressure affected different phases of different, elements. So Yeah, I'm just kind of scrolling up. Um, it's not really frozen, it's just crystallized. And it is cooling down, so eventually we can consider the whole thing frozen, but it's just became a solid, and that's due to the pressure and temperature and all these other wonderful, wonderful things. So, Hanny asked, so the crystal is still hot? That's a very good question, and I want to say that I don't think it's probably what we consider hot. Yeah, it's probably hot. But because it's still giving off heat, uh I'm really kicking myself for not paying more attention in physics and chemistry, and you guys are going to end up making me do a whole bunch of research. I would assume, like for us, the crystal would still be considered hot, but it is losing temperature. Veronica says frozen because it doesn't move, not temp, right? I think that's probably a better way to look at it, because it is essentially stuck in that configuration. It doesn't really move. And it doesn't really matter yeah. I think that's a better way of looking at it. It's more of like frozen in place than frozen in temperature. And I think it has to be below its melting point to become a crystal. And I've done crystallization stuff in OChem, and I really don't really... I'm embarrassed that I don't really remember. And I feel like, yes, it needs to be below its melting point for it to be a crystal, because I do remember heating up my crystals to find out what the melting point was. So, yeah, this is cool and wild and a bit beyond my understanding. But it's still pretty cool that we've verified something that, we were fairly certain was happening. Oof, oof. Wow, it's a lot of heavy science, and me really digging into those science classes I pulled into. My Cassidy says, wait until you're in your 70s, you forget where your feet are. Oh man, that's a ways away for me, thank goodness. So if anybody has any other questions, now is definitely the time to ask. I'm just looking at this picture on the other screen, and it's still kind of amazing. I don't think I have any of my little handy dandy molecules handy that I used a lot for OChem, because then I could show you, this is how things become a crystal. Or this is how atoms look like when they're in crystal formation. Hanny asks, how could a meteor hit the moon while it's facing us? I want to say gravity. There's a lot of stuff in the sky, and I have no idea how large the object was when it hit. I just know it hit. Graham asks, when will we get some more news from New Horizon, or will we have to wait for this shutdown to end? So as far as more space news from New Horizon, it's a PI-led project, which means it's not entirely under the government. I think all of their funding's already been dispersed, so they're free to do what they want to do. Normally, science results take a while to... You collect the data, you work on the data sometimes for a very long time. You get the data ready to publish. That takes an entire process. And then there's an embargo, meaning that, you know, your publishing stuff is kind of out there, but nobody can really talk about it. It's kind of all this big hush hush, especially if it goes into a journal like Nature. And then finally, when the embargo is lifted and it's been published for reals, that's when a lot of stuff comes out. So, yeah. Oh, did we get bits? We got bits, and I didn't hear it. So I don't know what's up with that. I may not have. I think Streamlabs is just acting up today. But yeah, thanks for the bits. I'm gonna blame Streamlabs acting up because I totally didn't get the notification. If that rock hit the Earth, what level incident would we be speaking of? Again, without knowing the size of the rock, it's hard to say. It could be anything from like a shooting star to somebody's car getting squished, which totally has happened. I hope that they'll release information on that soon. I'm sure somebody's studying that somewhere. String theory does impact calc. I wish that was a command for Nightbot. Nightbot, tell me how big this thing was that hit the moon. Hanzo says, taking a wild guess here, but my money is on Pretty Shooting Star. I'm going to guess that too, actually. There's a lot of stuff that just falls into our atmosphere and burns up because, you know, our atmosphere is awesome and does us a solid. So it would have to be pretty big to even make it part of the way. TPI says, Jarvis, can you calculate the angle the meteor hit the moon? Hey Alexa, what was the size of the meteor that hit the moon?
I don't know that one.
You didn't hear her, but she said, I don't know that one. And not even one of those big fat long ones either. We're talking blink and you missed it sized. Yeah. Yeah. Should have asked Google Home. I'm sorry, String Theory. I did not mean to set off your Alexa. Hanny says you should have asked Google Home. I don't have Google Home set up. There is one in the house. I apparently made my Alexa upset. There is one in the house. It's not set up because apparently it's a bandwidth hog and makes video games lag. The more you know. Yeah, they're nifty little things. Smart speakers are cool, but you know, people get really freaked out by them, and then I have to remind people that this is with you all the time. That's with you all the time. All the time. Google really freaks me out, and yet I use it. Yeah, there are so many neat things with my smart speakers, so yeah. Oh, it's been quiet on the dog front today. I know. Don't call it? What do you mean, don't call it? Meaning, don't call them out on it? Wolfram Alpha is pretty freaking awesome, and I loved using it. DPI says, once he says the dogs were quiet today, they'll start barking. I put the barky one in my lap, and she's the one that instigates everything. So, and the other one's just chilling. He would be, I could turn on doggy cam, but he'd be slightly off camera. So they're just chilling today. Yeah, the Cheerios are on my desk. Let's see if I can lift this to show you guys. Here are the Cheerios. She heard me lift it off my desk, but I didn't pull up the thing. Yeah, Tinker is Tinker is totally the barky one. She is the smallest one. She sounds mildly ferocious to strangers, but she's not the one that'll bite you. Fun fact. The cutest dog is sometimes the deadliest dog. Veronica here says that's why I have tap, so it doesn't listen until you tell it to. Yeah, I don't know if I can set up the Google Home like that. I know I can't really set up Alexa like that, and I have all of that stuff disabled on my smartphones, like Siri and whatever Samsung's equivalent is. DPI comments, the barkiness of dogs is inverse proportional of the size. It is very true. Oh my goodness. Little dogs get away with murder. Murder. Meanwhile, if a larger dog did that, they wouldn't be continued. Everybody thinks it's cute when little dogs bark and, oh look, he thinks he's a big... No. I know. Especially if they're friends with bigger dogs. Security. Yeah. What happens... Hanny asks, what happens to the planets of a star that is outgassing? Do they fall in? I assume you're talking outgassing like a planetary nebula. So this is actually going to happen to our sun. Way after we die. This is not going to happen anytime soon. But our sun, which is a yellow-sized star, pretty average yellow-sized star, is going to swell up, become a giant red star. Earth is going to be swallowed. I believe a good portion, because red giant stars are huge. Our entire solar system might be swallowed up by this red giant when it expands. So by the time that our sun does finally collapse upon itself and become a planetary nebula, the planets are already going to be gone. I'm not entirely too sure how the name planetary nebula came up. Just a regular nebula are essentially the birthplace of stars. They're really, they have a lot of gas, a bunch of things happen, the stars form, etc., etc. And this may have just be a historical holdover from when they could see that there was a bunch of gas, but they didn't know what caused it. So I always thought that was really confusing when I was in and about the planetarium when I was younger. You don't want to leave early. Okay. And we don't play soccer historically. Ay. So yeah, by the time that happens to our sun, all of our planets will probably be gone. And I imagine that will be the case for any other similar star systems with planets. So yeah. You are being quiet, aren't you? Isn't there some debate as to whether the Earth will be swallowed? I think the argument is that the sun will lose a lot of mass before it swells up, so the Earth's orbit will be larger. I really don't know. Again, for those of you that are new or don't know, I know literally enough astronomy to be dangerous. It's a very good question, and I don't know the answer. As DPI says, we'll see in a few billion years. Yeah. I mean, this isn't... Because this is something that takes so long, we can try to simulate it with computers, but I don't know if we've ever really seen this actually happen. Because it does take so long, and we essentially only get snapshots of what's happening in the universe. We may or may not figure that out. Alexa, put the end of the sun on my calendar. Alexa, put the end of the sun on my calendar.
I don't see a calendar set up.
I don't have a calendar set up. so I can't do it. Even if it doesn't, the sun could basically blow our atmosphere, rendering uninhabitable, as if the heat from being next to a giant star doesn't get us first. Yeah. The sun becoming a red giant just spells out death for our planet in so many ways. So many ways. It will only be burned or also swallowed. So many ways we will die. That's mildly terrifying. The ocean will boil in 100 million to a billion years first unless we intervene. And this is why we want to inhabit other worlds, because we would like to continue living. The universe loves to kill us. Yes, the universe loves to kill us. Also called crispy time. Let's move to planet 9. There is no planet 9. There's no planet 9. There was some stuff happening at the edge of the solar system. It's not a planet 9. I think they're still looking though, but what they found was not a planet 9. That's also a really long way away. It takes us, what, like, years to get to Mars? Is any water ocean the same if there is no reference scale? Sure. If we're categorizing water as, like, H2O. No planet 9 proving a negative. Months to get to Mars. I'm talking for humans to get to Mars. We can't go as fast, or there are things that we have to do. I think it actually would take years for humans to get to Mars. Maybe it is months. Maybe you're right. I don't know. It takes a while to get to Mars. Where was it? Planet 9 canceled. Ratings were too low. Latest theory is a string of objects whose mass adds up to a log. Yeah, but what kind of log? Like, are we talking like California redwood, or are we talking, you know, your average pine tree? But still, not a planet. About 9 months. Time to have a baby on landing. Oh, that's mildly terrifying. SpaceX are hoping to get Starship from Earth to Mars in about 3 months. That's still a really long time to be on a spaceship. If I recall, they're waiting for 2023 to prove the existence of Planet 9. Mars human transfer is about 200 days at best. SpaceX proposes 80 days. Those are still too long. Hi! Smee1 Leap. Hello, welcome. Yeah, I am not well versed enough in Dune to grasp what Fenring is chatting about. String Theory asks, I mean, the varying gravity affects the size of waves, but the frequency is the same. I'm assuming you're talking about oceans? I don't know. I think there's a lot that goes into waves. Hey! They couldn't hear you. Do you want to say hello again?
Hello. I'm Tinker.
Bad auto mod. How big is the spaceship while traveling to Mars? I'm not sure. I think Tink is arguing to wait for more data on Planet 9. She totally is. Also, she's saying hi to favorite human, who is literally just off camera. Don't get her worked up. Don't get her worked up. Here, have a dog. Here, you got her worked up. Now you have to deal with her. Here's a Tinker for the stream. And there goes a Tinker.
Oh no.
You got her? She's like a long, squirmy football.
Hello, Dobby.
Alright. So, with favorite human being home, I think I'm gonna call it. Because I would like to I'd like to spend time with favorite human. It's his day off. So thank you all for tuning in. And asking questions and all the other things. Pamela will be back tomorrow, hopefully. This has been a production in association with Planetary Science Institute in sunny Tucson, Arizona, and Youngstown State University in very cloudy, still very snowy, Youngstown, Ohio. Thank you for the bits. My bits notification are not working. I will toss... You could see just his elbow in the thing. I will toss Cheerios at them. Are you ready? Are you ready? Here are the Cheerios. Ah! And then here are the Cheerios for Tinker. No? She's like, no, I don't want Cheerios. I want you. All right. I have a dog orbiting my location. I do. And it's awesome, isn't it? All right. So, yeah. Alright. I'm going to take all this silliness off camera. So thanks all for tuning in, and I'm going to get ready to awkwardly roll the credits, and yeah. I will see you all later. Aye. Alright, thanks again all.